Hey, this is Passy from Passy's World of ICT, the guy with the white hat. And today we've got another Python tutorial for you. This time we're going to be looking at using Python for prototyping. And so, yeah, it's a great language if you've got kind of a complicated algorithm you want to test out and get all the code and logic working. Python, especially using the Python Room online emulator, is an excellent way to do that. So let's get started. Okay, so using Python for rapid prototyping, it's a language we can use for doing that. All right, so what is rapid prototyping? That there is an actual picture of the first mouse design they had. It was kind of this wooden block with a roller and a button on it, and they could move that and roll it round, and that worked as a mouse. But that was a prototype to get the idea and test to see if it could actually work and do stuff on the screen. But of course now we've moved well ahead of that, and we've got like the Mad Catz Rat Pro mouse, gaming mice with all sorts of ergonomic features, custom programmable buttons and things like that. So rapid prototyping, that involves getting the parts of the system at an early stage and doing an investigation. So we build a model as a starting point, and we play around with that and get it working. And usually then the prototype is kind of thrown away, and then we look at getting sort of into some really detailed, serious building that's going to take, you know, several weeks or even could take months to build. In the case of software, something which we're able to prototype in just a few days or even less than a day or a few hours in Python. Okay, things to remember are the conventions. So you need to have done our previous lessons, especially the lesson that was on Python. Like, make sure you've done that, because we're just going to go through Python really quickly here and then get into the prototyping. But there was Hungarian notation where you need to name things, you know, with int in front, like int number, to show that's an integer value. str name, well, name's going to be stored in string format, so we've got the str for string. And having that camel case notation where we don't leave spaces, or if we do leave spaces, we can use them with an underscore. So for this prototyping, we're going to be using the free Python Room emulator. And in our previous video and lesson on Python, we went into this in detail, so go back to that if you need to and look at that lesson. There's like an index in the YouTube description for that previous lesson where you can just go to various points and look at them. So you could go to the Python Room point in that previous video and look at it. But yeah, basically it was a matter of getting the web page going, clicking get started, deciding to join with email here, typing in your email address and setting up a password and clicking join. All right, now once you've done that, you'll be into Python Room and you'll have an account. When you want to make a new program, you just go to the green plus and click on new file. You have to type in the name of the file and press enter. And once you've done that, what will happen is that the Python code window editor will open up, and you can put your code in this black sort of area here. And when you want to test your code to see how it's going, use this little green button here. Now you don't have to worry about saving the program. That's all done automatically. And as soon as you click on the tab on the X next to a program, that closes it down in Python Room and automatically saves it. Okay, now just a quick review of Python syntax. This was all covered in detail in our previous language. But remember, there's print if you just want to show some stuff on the screen, input if you want to get the users to type something in, and the sort of sharp hash pound sign here for if you want to put some comments in the code. When you're doing if something's equal to something else, you need to use the double equals, kind of like exactly equals. And there's a few other programming languages that do it that way. And not equals is exclamation mark equals. And we've got some examples there. Now remember the case, like int brackets input, it's very important that that int is in little letters, lowercase, because if you put it like a big int, that won't work in Python. So we're going to be making a prototype of a program that's going to calculate the electrical usage of various appliances around the house. And then once we know how much power they're using up, over the time they're running, well, then we can calculate the cost of running that appliance, all right? So some of the inputs we're going to need from the user is shown here. We're going to need them to type in the name of the device, so they might be putting in that it's a fan, or maybe it's a refrigerator or an air conditioner. So that's just string, and we don't have to specify anything important on the input, because by default, automatically, it's going to be string input. Now, when we get them to put in the watts rating of the appliance, if you look at appliances, somewhere stamped on there, it'll tell you like it's 200 watts, 500 watts, 1,000 watts. That's going to be an integer value because that's a whole number. And so we need to put int in front of our input when we get them to type that one in. Now the hours of use, we're not going to use an integer because they might want to put in 1.5 hours, like 1.5. So we're going to use float on that. So float allows decimal values. So that input needs to be a float data type. And the tariff, the electricity provider might have a tariff that's 20 cents for each kilowatt hour, or it could be 21.432 cents. So that can be a decimal. So that will need to be a float as well when we're getting that input off them. Boolean we won't be using, I don't think, in this program for our prototyping exercise. Remember when you're doing the if statements that you need the double dots as you write them. There is no else if in Python, and again use double dots in here. There is no end if in Python, okay? So it's all based on the indenting here, that when things are indented, they're part of that statement which came before them that has the double dots on the end, and you need to use the tab key to do the indenting. You can't just press the space bar to do it. Okay, now dividing values. When we're doing our electricity program, we have to take that watts value and divide it by 1,000 to get a kilowatts value. Now in Python room, there's a problem with dividing by 1,000, which we explained in the previous video. So we're going to have to use 0.001. Multiplying by 0.001 is the same as actually dividing by 1,000, and that one works in Python room. So we'll be doing it that way. Now subroutines, we're going to have quite a few subroutines in this prototype as we build it, because the best way to develop a program is by adding modules onto it step by step. All right, rather than writing some monster program that's just a whole lot of code that's very hard to look at. Because if you have it modularized, like we've got here, the main processor goes off and does all these other little subroutines, which are DEF, def statements in Python, def setup. Yeah, well, it's much easier if something's going wrong just to go into that one single def and fix the problem in there, rather than trying to look through some really long, giant program. So we will be using subroutines today, and we'll show you that when it happens. And we're going to be using some global variables, because when you're using subroutines, often you need one subroutine, like this one here, sumo calculation, is going to calculate the power cost using an electrical company here in Melbourne, Australia, called Sumo. And yeah, once we've got that cost in dollars, we need to use that in another subroutine later on. So that's going to have global in front of it to make it a global variable to do that. And if that isn't making any sense at all, go back to the original Python video before this one, and we explain all of that in detail. Because right now we want to get started with doing some rapid prototyping in Python. Okay, so the example we're going to use is power cost calculation. So we're just going to make a basic power cost calculator as our first project here, doing prototyping. So the power usage in plain English, all right, it's not quite as simple as calculating like the area of a rectangle equals its base times its height, or its length times its width. There's a few steps involved, and the first step is that you take that appliance which has some watts stamped on it, like how many watts it's using of power, like it might have 500 watts, and then you divide by 1,000 to get it into kilowatts, okay? Because we need kilowatts for our formula. So something like 500 watts divided by 1,000 would come out 0.5, so it's 0.5 kilowatt is the rating. Then we work out the power usage in kilowatts by taking that energy rating we just worked out and timesing it by the total running time, how long they've been running it for, in hours, okay? Because it's a kilowatt hour unit, we need to have the running time in hours. So if they're only doing 30 minutes, that would be 0.5 hours. And if they're doing like 15 minutes, that would be 0.25 hours. If you don't know how to get that, well, you just do 15 minutes, 15 divided by 60 would give you 0.25 because there's 60 minutes in 1 hour, so 15 minutes out of the total 60 is 0.25 hours. And then once we've got the tariff that the electricity provider is charging their electricity at, we can multiply that through and work out the cost in cents. Now, cents isn't great. People kind of think in dollars and money usually, rather than in hundreds of cents or thousands of cents. So we just divide that by 100 to get it into dollars. So look, here's a practical example of how power cost calculation works. So you might be wondering, you know, hey, we're running that big fridge in the kitchen and that has to go 24 hours a day to keep everything frozen or refrigerated. How much money is that costing us? Well, you can work out if it was a kind of a low-powered economical fridge that only uses 300 watts of power, times that by 24 hours, and that's 7,200 watts a day that refrigerator is using. Then if we divide that by 1,000, that's 7.2 kilowatts per day, and multiply that by 30 days for 1 month, and we've got 216 kilowatts per month. Now, the electricity provider here looks like a very cheap one. They're only charging 10 cents a kilowatt hour, which is like phenomenally cheap. And that'll mean $21.60 a month. That's how much it's actually costing you to have your refrigerator on and run it. Okay, so someone might be kind of in their apartment in wintertime and wondering, gee, how much money could I save if maybe I don't turn on that wall heater or the heating at all, and yeah, I just kind of rug up to keep warm because, you know, that poor young girl, she's probably a millennial paying like maybe half of her salary just in rent. So half of her wages in rent. So she's thinking, how can I save a few dollars here and there because I want to go traveling and take pictures and put them on Instagram and do fun stuff. So yeah, would it be worthwhile rugging up in a blanket and not running your heater? Okay, so electric power usage, as we said, is expressed in the kilowatt hours. So if it's a 2,000 watt heater, that's kind of the typical fan heater here in Australia. If you're going to run that for 3 hours after you've got home at work, that's going to be 2 kilowatts that you're doing for 3 hours. So the 2,000 watts divided by 1,000, that's going to be 2 kilowatts. And for 3 hours, that's going to be 6 kilowatt hours of power usage that heater has taken up. Now, the energy price set by the power company, that's called the tariff, and that's in units of cents for each kilowatt hour. So her power company is charging her 20 cents per kilowatt hour. So if she's doing 6 kilowatt hours of power usage and each kilowatt hour costs her 20 cents, well, the total cost will be the 6 kilowatt hours times 20. So it's going to cost $1.20 to have that heater on for 3 hours. So yeah, rather than rugging up in a blanket, might be worthwhile just running that heater. But see, that's where this power cost calculator is going to be a really useful app for people if they are thinking about, you know, oh gee, all these things in my house are using all these electricity. This will give them an idea of actually how much it is and whether it's worth, you know, really getting minimalist and like trying to go without electricity and appliances and things. So the power usage algorithm for our program is that we're going to have a begin at the top and an end at the bottom as usual. And the things we need to get off the user are, we need to find out the watts for that electrical appliance, how many hours they're planning on using it, how much the electricity provider that they're on, the power company, charges, what that tariff is, and then we can put it into all those formulas we were just talking about. And the output that we're going to tell the user is how much did it cost them in cents and how much did it cost running that appliance in dollars. So we need to translate these steps here, the algorithm steps, where we've kind of worked out the main logic and structure of the program in plain, simple English, just so we can sort of understand it all. Now we need to convert that into Python language, okay? So first up, we're just going to write a comment, which is always a good thing at the top of the program. So this won't do anything, but it will appear in the top of the program listing. This is the Python program to calculate electricity charges. So we're actually going to get the device name off them, find out what the device is they're running, whether it's a heater or a fridge or whatever. So that's an input. Then we'll get the watts. Now remember, watts need to be in integers, so we're going to have int input in front of it. The hours of use could be a decimal. Remember, 0.25 hours is 15 minutes, so they might want to do decimal. So we're going to put a float in front of that when we ask for their input. And the tariff charged by the power company could be something like 20.5 cents. So that could have a decimal. So that needs to be float rather than being integer in front of that. So that gets all of our user inputs. And then we can start doing our calculations. So the energy rating, we need to take their watts they've given us and times it by 0.001, which is the same as dividing by 1,000, but Python room can't handle dividing by 1,000, remember that. And then we can get our usage kilowatt hours by multiplying these guys together from the inputs, work out the cost in cents, and then divide that by 100, which does work okay in Python to get the cost in dollars. Then we'll just print a blank line, just have a bit of space and make it look neat and tidy. And then we'll tell them what the cents cost is, and we'll just print a blank line to have a bit of spacing in the output so it's not all crammed up together. And then we'll tell them what the cost in dollars is. And then we're pretty much done. So let's jump into Python room and do this and see how we go. Okay, now, where do we need to go first? First, we'll just go over to here. If you go to the YouTube description, you can download this presentation and it'll be a PDF document. And if you've got the download, well, then you'll just be able to take your mouse and color all this in. So get the download. This particular download's free. And we can just go Control-C to copy that into computer memory. No. Okay, so we're in Python room. We've got an account set up. We're just going to do a new file here, and we're going to call this Power Calculator. I'll just call it Power Calc Video, because this is the one we're doing for the video. Okay, so we've typed the name in. Make sure your cursor's at the end of the name and press Enter, and that'll open up Python room. Now, if we do Control-V, it's remembered that code and typed it in. The only trouble with the PDF is, though, that it doesn't do the new lines properly, so not everything's on separate lines like it should be. If we try and run this right now, see, it's just going to bomb out and have some problems. So we need to sort of think about what were the steps. So the first one was getting the device name, and that actually finishes there. So we need to go across here and press Enter. Then we were getting the watts. Then we're getting the hours of use, so we need to press Enter. So these things are missing their carriage returns or line feeds or enterings. So we need to fix all of that up by figuring out where the line ends and where the next one starts. Click in that point and just press the Enter key. Then we've got our usage times tariff. Then we've got our cost in dollars. Then we were printing that blank line. We're doing the cents cost. Then we were printing another blank line, then we were doing the dollar cost. Okay, so I think they're all separated so that they should follow the pseudocode, but we've just translated into Python language. So fingers crossed, let's go to the green arrow here and Pythonate it. Oh, and it is actually working. Okay, so let's say they're just running a fan to keep cool because it's actually summertime here in Australia. And let's say that's an 1,000 watt fan. So we put in 1,000, press Enter. How many hours? Well, we're going to have it on for like 4 hours. The tariff that the electricity is providing is 22.5 cents. And so the cost of running that particular fan for the 4 hours is 90 cents or $0.9. Okay, so yeah, we might as well have that fan on and it's going to cost us less than $1. Okay, so that is our sort of power calculator prototype working. Now, it doesn't look all pretty running in this box, but at least we have all of the logic set up here and we know what to do if we're going to put it into something fancy with a screen form or with perhaps a web page running behind it. Okay. Let's go back to the PowerPoint. All right, so that is the completed code, which we just looked at for the power cost calculator. And when we run that for various things, it works fine and tells us the dollar cost of running that appliance. Okay, so now there's a Python code editor, Notepad++. Notepad++ is free to download, so get a download of that. because then what you can do is on the language tab, you do have to click up the top here on language and just set it to P. Go to the letter P when the language drop-down list is there and pick up Python and set it to Python. Then you can actually just like highlight your code, which is in Python room, and just Control-C and Control-V it into Notepad++. And then you can see Notepad++ does do some different sort of colorings, so we can pick up sort of key Python words and a few different things. So it makes it easier to read than just having the text all the one color. And then you could save this Notepad++ file. So at least if, you know, your Python room login stops working or something goes wrong with Python room, you've got a spare backup copy of your code here. So that's well worth doing, and Notepad++ is free. Now, some of my students did actually get these plugins as well. So you can get like a plugin for Notepad++, and then you'll actually be able to run your Python like we did in Python room. So you could just use Notepad++ as a substitute for Python room. Now, we sort of haven't had time to try that out and get it working properly, but there was a video we found here. We're not guaranteeing that it works, but look, it can be done because our students have done that, and they said, yeah, it's just a matter of getting the right plugin running, and then you'll be able to actually, I think, click on run up the top here, and you can pick that plugin and run your Python code. So Notepad++ can also be used for Visual Basic and other languages as well, and I think you can download plugins to run the code and see if it is correct and is going to work all right. So we're going to move now to doing power cost comparison calculator. So an extension of the project we just made is to make some power cost comparison tools, and that's what we're going to do next. To tell you the truth, at the start, we wanted to make a big power cost comparison tool, but like trying to make something all at once like that is too hard. It's like trying to sit down and write a novel or something from start to finish. You want to break it up, like writers break their novels up or whatever they're writing into chapters, or people that are doing a travel blog online will break it up into blog posts, different days, different places they've visited. They're not going to try write the whole massive thing all at once. So that's what we're doing here. We're just breaking it up into bite-sized chunks. So there's several organizations offer online calculators where you can compare the electricity bills to see whether swapping over to this different power company would be cheaper for you. So we did some research on the internet, and these were 3 local companies in the Berwick area, which is just a suburb of Melbourne in Australia here. So first we had a company called Simply Energy, and this is their power bill calculations. And we've decided that the tariff we're going to use is the 23.681 cents tariff, okay? Because we're just going to be working out the cost of running appliances. We're not doing the actual whole bill, so we're not worried about the pay on time discount. Now the 1,000 kilowatt hours you get per quarter, so that's like 3 months. You're going to use that up really quickly, so you're not really paying that low price. You're going to be on remaining kilowatt hours for most of the quarterly period. So this is effectively, this 23.681 is effectively their tariff. Then we looked at the Sumo Power Company, and they've got a cheaper tariff, like theirs is 21.199 cents there. So we're going to also look at them and compare them. And finally, there's a company, AGL, that seemed to be more expensive than the others. And so they're running kind of a tariff of 27.302 cents. So remember, we're only comparing electric appliances, not the monthly or quarterly power bills. So we'll just be running off these 3 values here to use as our tariffs to compare the different power companies and work out, like for running our heater for 4 hours, which power company would be the cheapest price for running that heater, or running our refrigerator or whatever appliance we want to look at. So first up, again, we'll break it down into chunks. We won't try and compare all 3 power companies at once. We're just going to compare what we've already got from our program where we enter the tariff for the power company we're on at the moment. And we're going to compare that with Simply Energy. So we need to write some subroutines now. So you can see here we've broken our program up. We've got a def, a procedure here. This was the code we just used in our power calculator where you put in what your company's tariff is, because I might be on a different company than those ones there, okay? So That's your current power company tariff. It does all that stuff like it used to. Now we've got a new subroutine here called Simply Energy Calculation. All that does is take the usage kilowatt hours, and instead of using the user input value, it uses that 23.681, which we just worked out on the previous slide. If we just go back to that, and okay, we have to go back a couple to get to that. Yeah, see, this Simply Energy tariff was 23.681, so we're just going to use that and put that in, and then that can work out the Simply Energy cost here, and then we can just put out to the user what their cost is at the moment with their provider and what it would cost with Simply Energy. So you can see when we do the program run here, hairdryer 2000 watts and so on, the dollar cost at the moment with their power company is 10.75, about 11 cents. With Simply Energy, it's actually going to be over a lot more. It's going to be 11.8 here. So Simply Energy is not going to be cheaper for them running that hairdryer. Okay, so we sort of do that and add that module in and get it all working. And down the bottom, we've got a main processor that does our original program and also does the new Simply Energy module that we added on. Okay, now we're going to sort of do some enhancements to that version. And what we're going to do is add on another module. So in the main processor here, we've got the Simply Energy comparison. So we're going to add on that as a new submodule. And what that submodule is going to have in it is this code. So this subroutine or this sub-procedure submodule here, it's just going to check, is the Simply Energy cost cheaper? Is it less than their normal cost for the appliance? And if it is, we'll write Simply Energy is cheaper and tell them what the cost is. But if Simply Energy is not cheaper, we'll just say Simply Energy is not cheaper and tell them the Simply Energy cost. So when you run that, we get some extra output at the bottom here now. We get some sort of AIs the program figures out for us. We don't have to look at the values. It tells us Simply Energy is not cheaper, because you can see it's 1.808 there, 1.8944 is bigger. So Simply Energy is not cheaper. Okay, so that's our second version. So we build these things up gradually and don't try and write them all at once. So attaching additional modules one by one and testing them as we go. This is how you do application development. This is the way it's done. It's called modularized programming. Okay, now we get into the full price comparison calculator. So this is kind of like, there's a thing in Australia called Compare the Meerkats, where you can go to a website and it like compares prices, I think for insurance or something. But this is kind of like our full-on Compare the Meerkats calculator that's going to compare all three power companies. And so the code, by the time we've done all three power companies, does get quite big. But really, just to do Sumo and AGL, we're pretty much copying and pasting the Simply Energy code we just wrote and just changing the tariffs. So here's some runs here of what the finished one looks like. So when you put in a heater that's 2000 watts, running it for 4 hours, the current provider we've got here is 22.5 cents, okay? And the cost is $1.80. So then it works out the three power companies. So it tells us Simply Energy is not cheaper because it costs more. Sumo is actually cheaper. Running that appliance would be cheaper on Sumo. AGL is not cheaper, and it tells us the AGL price. And then we also have a final thing here which tells us which of the ones is the cheapest and what our cost savings would be on running that appliance if we were with that power company. Okay, so we've just tested out for a few different appliances here. A 1500 watt dishwasher is going to be cheaper on Sumo, and we'd save 11 cents while we're washing our dishes with Sumo. Okay, now is 11 cents a lot of money to save? Well, you've got to think about the power of compounding. And if you run your dishwasher every day like we do, over a month, 30 times 11, what's that looking at? Like $3. So you've saved $3. Over 12 months, you've saved $36. And then if you were saving like $36 on, I don't know, 5 or 10 different appliances around your house, that's sort of getting, you know, $200, $400 a year, which would be nice spending money to have when you go on a holiday. So look, these values here might look small, but remember, think of the power of compounding. Think of 30 days, think of 365 days in a year, think of 5 years and 10 years. If you can make all these little savings, they all add up. Okay, so here is the full-on code listing. Now, don't be frightened by this. It looks really complicated. But look, that was just our original calculation. And this was when we added on Simply Energy. And all we've done is add on a Sumo one here, which was pretty much just copying and pasting the Simply Energy stuff that we had, but changing the tariff to the Sumo price, which we have put at the start of the program. We just might mention that. It's best to put your prices up here at the start and refer to them down in the program, because then what will happen is that if Sumo changes their price when you're doing this a couple of months from now, you can put in the new price here, and you don't have to go hunting around for the Sumo price in every module in the program to change it. We only have to change the things once at the top. So that's a good idea, setting up global variables and just having them appear once at the top with the values. Okay, that's something experienced programmers would just know how to do. And so we've got all these comparisons here. Now, the finding the cheapest subroutine looks really scary when you look at it. Let's take a look at it now. Whoa, look at that. There's just all this stuff and lines, and oh my goodness, I'll never understand that. But look, in reality, it's not that bad, because it's just saying here, float the user cost. So this is how much it costs for the person on their current electricity company, and you're just checking if that is less than or equal to, if that cost is less than AGL, Sumo, and less than Simply Energy. If it's less than all three of them, well then the one you're on now is the cheapest. So string cheapest provider is the user tariff. And then here we're checking Simply Energy. So we're just checking Simply Energy 3 times. Is a Simply Energy cost less than? Is it cheaper than AGL? Is it a lower cost than Sumo? Is it a lower cost than the current user ones? If it's lower than all three, well then Simply Energy must be the cheapest. So we just put string cheapest provider equals Simply Energy. Okay. Else, if we go down here and we check, is Sumo the cheapest? And we'll just check whether AGL is the cheapest. And then once we've done all that checking, we can print out who the cheapest was. And we can also work out the cost savings just by subtracting what the user's normal cost is compared with that provider. Okay, so in the main processing down here, we now have 1, 2, 3, 4, 5, 6, 7, 8, 9, I think. 9 different defs, 9 different subroutines that do different jobs. The find the cheapest, the last one was the biggest one, looked a bit scary, but if you kind of look at the code for a while and think about it, it should make sense and not really be that bad once you've sort of understand how it's all working. Okay, so the comparison calculator, this demonstrates the power of prototyping in Python. We were just able to start a little program in Python to work out how much it costs to run an appliance, and then we were able to expand that out to a whole compare the market program and all of that. So the code could be now delivered to a web developer who could put a nice front-end screen onto this, so that this could be an online app where people actually log in and put in their current cost, put in their appliance. It could do some calculations for them and work out which energy provider is going to generate cost savings for them, okay? So the typical online app which people are using, especially here in Melbourne, to compare their providers and swap electricity providers to save money. Okay, so that's the end of the presentation for prototyping in Python. We hope it didn't scare you off with that code. So web developers, yeah, this is just a funny slide for us to have a look at. Yeah, what my mum thinks I do. She thinks I poke out my tongue a lot. Well, maybe she does. Yeah, so isn't that happy feeling when you get your Python code running? It is a good feeling. And Python actually is really booming in artificial intelligence and automation at the moment. And there's a lot of jobs in Python because of that. So AI is a really big thing at the moment. So learning Python is worthwhile. What you've learned here won't get you a job in AI, but at least this is a start in Python and kind of a small demonstration of where it's useful, especially for prototyping. So look, have fun coding with Python. We hope you've enjoyed this tutorial. Most of our tutorials leading on from here are probably going to be on Visual Basic rather than on Python, but we're hoping kind of later on, it might be in a few months, it might not even be maybe for 12 months, maybe not till next year. We're hoping to do some more Python programming tutorials, but at least this has given you the look and the feel and how to do kind of all of the basic algorithmic programming structures in Python. And so subscribe to our channel. We're putting out videos every week. Make sure you go to the description for this one and get yourself the free download of the presentation, and we'll see you at the next tutorial. Like this video if you found it helpful.